So today we are going to be making an amortization plan for amortization of fixed capital and interest. And what I mean by fixed capital and interest is that the entire payment that includes capital and that includes interest is going to be the same each time. And this is pretty common, right? If you get a fixed term mortgage, typically what that means is that you're paying the same amount each month, right? Or if you get a fixed car payment, you're paying the same amount each month, right? Each time you pay, it's the same amount. So let's talk about how we can set up a plan like this. A bank granted a loan of $25,000 at a 10-year term with annual payments and an interest rate of 9% annually. What is the amortization plan with a fixed payment to capital and interest? Okay, so first we're going to write down what we know. We know that the loan amount is $25,000. We know that the term is 10 years. We know that the interest rate is 9% annually. And we know that the amortization is also annual as well, right? Because we're making one payment every year in this hypothetical. Of course, monthly payments are actually a lot more common when it comes to this stuff, but for this exercise, we're going to be doing yearly payments because if we were to do non-yearly payments, that would be, that would be something else. That would take a lot longer of a time for us to write an amortization plan. So in a lot of these kinds of school questions, they're going to tell you annual, or maybe it's going to be monthly, but only for like 6 months or something, right? Because otherwise it would take, we could be doing this for like 100 columns. But anyway, what is the amortization plan? So for the amortization plan, first I'm going to write down the years because that's our amortization period is yearly. Then I'm going to write down the loan balance, then the capital, then interest, and then capital plus interest. Okay, and actually let's maybe give a little bit more space, or actually maybe we're okay there. I'm just going to draw some lines like that. Oh. Okay. Then for number of years, I'm going to write the numbers from 1 to 10 because this is a 10-year term. So year 1, year 2, 3, 4, 5, 6, 7, 8, 9, and 10. There we go. Okay, then for loan balance, well, we know that the very first loan balance in the beginning is $25,000. So for year 1, we can go ahead and write $25,000. Then capital and interest, we're going to leave blank for now because we need to do some more in order to figure out what that's going to be. So what we need to do is we need to figure out the A value in our present value equation. So we're going to go back and just remind ourselves that the present value equation in general states that PV is equal to A times 1 minus 1 plus I to the power negative n over I. And this specific equation relates to the present value, not just of a fixed payment in compound interest, not just one payment, but when it comes to the annuities, because this is what is happening here. It's an annuity in the sense that we're making payments each time that are going towards paying off debt. So in this case, our present value is actually something we know. It's $25,000, since that's the amount of loan we're taking out in this case. A is what we don't know. A is what we would like to figure out. We need to know, okay, what is that payment going to be every time? If we're making equal payments each time to get this paid off, how much is each payment going to be? And that's going to fill our entire capital and interest column. So then we're going to have A times 1 minus 1 plus I, which I think I was 9%. Was that right? Yes, it was 9% annually. So 1.09 then we can just say to the power of negative n, which in this case number of years is 10. and then that's over 0.09. So actually, I'll write this out. PV was 25,000. The interest rate was 0.09, and N was equal to 10, just to kind of make it clear which values I'm using to plug in here. Okay, then the next thing I'm going to do is I'm actually going to simplify this because this looks very big and complicated and it doesn't need to. So let's do that. So what I'm going to type in is 1 minus and then bracket 1.09 to the power of negative 10 and bracket equals, and then divide by 0.09, hit equals again, and I am getting 6.417 and so on. I'm getting a very long decimal there. So therefore 25,000 is equal to 6.4176577. That's probably more decimals than we really need. I'm just going to round it off there because then after that it's 0, 1, and then some other stuff that we're not sure. And then A, and then therefore A is equal to 2,500 or 25,000, sorry, over 6.4176577. So let's divide that, and then we're just going to round to the nearest 2 decimal places for dollars and cents is generally what we do when we're talking about money. So divide by 6.4176577. And that gives me that A is equal to $3,895.50. So therefore, the payment that we must make each time, if we take out a $25,000 loan at 9% interest and we pay it back, in equal installments once per year, each installment that we need to pay, every payment we make each year, must be $3,895.50. So that's what I'm going to put in my entire capital and interest column because the payments are going to be the same. So I'm going to be writing that for all of these first. So first one, $3,895.50. Same with the second one, the third one. I'm just going to be writing this for all of them. And actually, let's make sure this lines up nicely. I'm going to draw some more lines here just to make this a little bit more clear as to what's what, because there's a lot here. Okay. Okay, so now that row is all done. Okay, so next thing we need to figure out is, all right, for each of these years, how much is capital and how much is interest? Well, the thing is, because we have to pay interest on the full loan balance, that means the higher the loan balance is, the more money is going to need to go to interest, and therefore the less is left over, so to speak, for the capital, right? So in payments 1, 2, and 3, we're probably going to be paying a lot more interest than capital, whereas in the later years, we're going to be paying probably only a little bit of interest because the loan balance is a lot smaller and most of the money we're paying is going to be capital. And sorry, I guess I should clarify, when I say in the first years we'll be paying mostly interest, it's not necessarily that the vast majority of $3,895.50 is necessarily going to be interest, but it's going to be more interest. We're going to be paying the most interest the first year out of all the years. And then the second year, we're going to be paying a bit less interest and more is going to be left for capital, and so on is how it's going to be. So to find out how much interest we are going to need to pay in year 1, what I'm going to do is I'm going to type in $25,000 to my calculator because that's our loan balance at the first year. Before we've made any payments, we still owe the full $25,000. I'm going to multiply that by 9%. So that means the amount of interest that must be paid in that first year is $2,250. Okay. So what that tells me is that whatever is left over from the capital plus the interest must be, must be able to go to the capital. So now I'm going to take $3,895.50, which is our full payment that we're making that year. Then I'm going to subtract the interest. So $2,250 of that is just interest to the bank. So extra fees that don't actually help us pay down the loan balance. If we subtract those off, we get that the capital, so the amount we're paying towards the balance of the loan, is $1,645.50. All right, next what we're going to do is we're going to subtract that from the loan balance, because after making this first payment, we paid $2,250 in interest. Unfortunately, that's just kind of gone. It's gone to the bank. We never get to see it again. But that $1,645.50 that's capital, well, that's money that we now no longer owe to the bank anymore ever again. Unless we borrow it again, right? But we don't owe that again, assuming we don't borrow anymore. So now I'm going to do $25,000 minus $1,645.50, because that's how much we just paid off. So therefore, we now only owe $354 left. Okay, so now in the next payment, we're going to owe less interest, because now we're going to take that number, $23,354.50, and we're going to multiply it by 9%. So let's multiply that by 9% to see how much interest we must pay on that one. Okay, so we still must pay $2,101.91 of interest for this one. So that means that for the capital, right, because overall the payments, again, is $3,895.50. So if we do the capital plus interest minus just the interest amount, we get $1,793.60. Although I guess I rounded up in both of them. So I guess, yeah, we could just say 59 cents. That's probably fine. Okay, so now that is money that we no longer owe on the balance anymore, so we can take that away from the balance. So $23,354.50 minus, now that we made that payment, now we owe $1,793.59 less than we owed before. So if we subtract that, we now get $21,560.91 that we owe left. And then we're just going to keep doing this over and over. So if you get the idea and you're done with this, fantastic. That's totally fine. But I am going to keep going throughout this entire thing, perhaps a little bit faster as we go along, because it's really just kind of tedious work at this point. It's doing the same thing. It's essentially, we're going to look at what the balance is. We're going to multiply the balance by 9%. We're going to get that, therefore, the interest that we owe on that balance is $1,940.48 this time. Then we're going to subtract that from our total payment to figure out how much is left in that payment that is able to go to principal. And in this case, it's $1,955.02. And then we're going to subtract that amount from $21,560.91 and get that now, at the beginning of year 4, we only owe $19,605.89. And then same thing, we're going to multiply that number by 9%. We get $1,764.53. We're going to subtract that from $3,895.50 to get $2,130.97 for capital. We're going to subtract that from our loan balance. So subtract that from $19,605.89, and we get $17,474.92. All right, now multiply that by 9% interest. So that year we pay $1,572.74 of interest. And then we subtract that from $3,895.50, and we get that the capital is $2,322.76. And then we subtract that capital from our total loan balance. So that's $17,474.92. Okay, so now at the beginning of year 6, we only owe $15,152.16. Then we multiply that by 9%. So then we have $1,363.69 of interest, and then subtract that from the total payment, $3,895.50. And we get that the capital paid was $2,531.80. And then we subtract that capital from our loan balance, so 15,152.16. And that's going to be, now we only owe $12,620.35. So then multiply that by 9%. We get $1,135.83 of interest. And now we subtract that from $3,895.50. So that's going to be $2,759.67. And then $12,620.35. So that means we only owe $9,860.68. Multiply that by 9%. We get $887.46 of interest we paid that year. So that means there's a lot more left for principal now. So $3,895.50 was the total payment. That means that 3,000 of those dollars, 3,008 of those dollars, and 3 and 4 of those cents, to be more exact, is going to actually paying down the balance, which is great. So 9860.68. That means we now only owe $6,852.64 multiplied by 9%, and we have $616.73 of interest we're paying that year. Then subtract that from the capital and interest, so the overall payment, and therefore the capital that is put towards it is $3,278.76. Subtract that from the total balance, $6,852.64. And now we only owe $3,573.87. Multiply that by 9%. We get $321.64. Subtract that from $3,895.50 for the full payment, and we get $3,573.85. And there we go. That was and that is equal to our loan balance, or basically, I mean, I suppose it's technically 2 cents away from our loan balance, but if it's something so close like that it's off by like literally 1 or 2 cents, probably just from, some rounding in there at some point. So that's totally fine. If those numbers are drastically different, like even if they were $1 different, I probably would be concerned that there was some mistake made, although that does also depend on the context of the problem that was asked to you. I will also say that that if you add up all the capital and all the interest together, that should add up to the same as $3,895.50 times the 10 payments overall. So that overall should add up to $38,955, which it does, or it could be within a couple cents of that. The other thing I want to note is that notice that the interest is very high at the beginning, and then each time the interest we're paying every year goes down and down and down because the loan balance goes down and down and down. And so we're paying the same percentage of interest, but it becomes a much lesser amount of money because there's a smaller loan. And then the capital, therefore, since we're making the same payment, that means if less of that payment is interest, that means there's more of it left that has to go to capital, that has to go to actually paying off the loan balance. So notice in the first year, we're actually paying more principal than interest. In fact, in the first 2 years, more of the payment is just going towards interest, so fees to the bank for letting us borrow this money, than is actually going towards paying off that balance. In year 3, slightly more is going to capital, but it's very similar. And then after that, the capital keeps growing, and by the end, we're paying mostly capital, and we're paying very little in interest in comparison to our capital, because a lot of the loan by the later years has already been paid off, right? And so even though we're making the same payment, because in the earlier years we're still owing a lot more on the balance than in the later years, that is the reason for this. And you'll notice this on your mortgage statements as well, that in the earlier years of paying off your mortgage, most of that is just interest. And then in the later years of paying off your mortgage, most of that is principal. There's not as much interest that you're paying in comparison to the interest you were paying 5 years ago or 10 years ago, assuming it's the same mortgage, same terms, and that other stuff hasn't changed that I'm not accounting for here. So those are just some key takeaways, is make sure that you're in something like this, your capital does go up each time, that your interest does go down each time, making sure that your capital plus interest column adds up to the total of when you add up the capital and the interest together individually as well. Those are some great things to keep in mind when making a sheet like this. But anyways, if you have any questions, please leave a comment in the comment section. Oh, I will also say one more note. Normally, a computer would make this kind of sheet. It is good to understand how it works and to be able to do it yourself for an example like this. However, in a real life scenario, like if a bank is giving someone a mortgage, there's no way that in this day and age, especially, that there's someone typing on their calculator making all these calculations themselves. Like they're for sure having some sort of spreadsheet or computer program, something like that, to do this for them. It's good to have a human take a look at it and make sure that there wasn't some error or something that happened, because computers can make mistakes, especially if it comes to maybe there was some human error in making sure that the program was set correctly or that things were typed in properly. So it's good for a human to take a look at it and stuff, maybe before showing it to the client. But, so it is good to know how this works. However, it's not like you're going to ever be asked to by hand do this like 360 times for some mega mortgage that's going to be coming out of someone's account every month for the next 30 years or something like that. So that is just something to keep in mind too. All right, but that's everything for this one. We'll see you for the next one.